Hello, everyone. We're going to start this unit on rational expressions. And when you think of a rational expression is a polynomial divided by a polynomial. Oh, my pen, there it goes. It lets me write. Rational expression. I'm going to use EXP for expression. Is a polynomial divided by a polynomial, which means we're entering this world of fractions, and the fractions are going to have variables in it. The first thing we need to talk about is restrictions. So what type of things can I not plug in for x? Can it not be evaluated? And it's not going to be possible to evaluate anywhere that denominator is equal to 0. Because remember, we cannot divide by 0. So to find the restrictions, we're just going to set each denominator equal to 0, and then we're going to solve it. So in this case, we're going to add 5 to both sides. So we're going to get x is equal to 5. So what we're doing is we're finding something I like to call the issues. Where are the problems or the issues? Well, 5 is an issue. So everything except 5 would be fine. So we're going to write it this way. We're going to think about this in terms of something called the domain, which is what kind of x values can I plug in, and I'm going to say everything except 5 for that answer. So the next one, we want to find restricted values. We have 3x over x squared minus 4. We're going to have restrictions anywhere that denominator is equal to 0. So that factors as a difference of squares, x plus 2 and x minus 2. And we're going to set each factor equal to 0. So x plus 2 is equal to 0, x minus 2 is equal to 0. And then we're going to solve for x. So we're going to get 2, and we're going to get negative 2. I forgot the negative on that first one. So our domain, I'm going to think about this as domain, is going to be x cannot be equal to negative 2 or 2. And this is where you may want to pause the video, try the next one, come back and check your answer. So we have x minus 1 over x squared minus 9x plus 20. We want to find restrictions. So we're trying to find those issues. We're trying to figure out where is that denominator, x squared plus 9x minus 20 equal to 0. So we're going to use our AC method. So that's going to be 1 times a 20, which is 20. 20 factors into 4 and 5, or negative 4 and negative 5. And if you need to write a few more factors out to find that combination, that gives you that middle term of negative 9, that's fine. Negative 4 and negative 5 is going to be our winner. That we have x squared minus 4x minus 5x plus 20. So that middle still adds up to that negative 9. Now we're going to group the first two together, factor out an x, leaving me with x minus 4. Factor the next two together, we're going to factor out a negative 5, leaving us with x minus 4. We do have to factor the negative out so my signs work. So I've got that group x minus 4 in common. And that's going to leave us with an x minus 5. And then we're going to set each of those factors equal to 0. X minus 4 is equal to 0. X minus 5 is equal to 0. And then we're just going to solve. Add 4 to both sides to get a 4 as a restriction. And add 5 to both sides to get a 5 as a restriction. So our domain, I'm going to think about this as domain, would be x cannot equal to 4 or 5. Those are our problems. That's what makes the bottom equal to 0. So now we're going to think about simplifying rational functions. So we have 4x squared over 8x cubed. So there's a lot of different ways you could think about this. Here's the way I'm going to think about this. You guys remember back when you were talking about fractions, maybe in elementary school, you had 6/8, and you're trying to figure out how you're going to reduce it. So we said that 6 was the same thing as 2 times 3, and 8 was the same thing as 2 times 4. And you said, oh, look, I've got a 2 on the top and bottom, so they're going to cancel because 2 divided by 2 is really 1, and that's going to leave us with the 3/4. The same concept's going to apply here. So I'm going to think about this as 4x squared, which is 4 times x, over 8x cubed, which is 4 times x times x times x. Oops, I forgot my 2. Let's try that again. 4 times 2 times x times x times x. So I'm using the same concept that I did with that 6/8 that we did up here. So what do they have in the top and bottom that's going to cancel? Well, the 4s are going to cancel. Also, I have an x here that's going to cancel, and I have another x here that's going to cancel. So now I'm going to think about what's left over. On the bottom, I've got a 2 and an x left over. And the top, I don't have anything, but remember, everything's really multiplied by 1. There's an understood 1 there. So that's what I'm going to have in the numerator. So my final answer is going to be 1/2x. And when we think about restricted values, we're going to think about that domain. What kind of x values can I plug in? It's always going to go back to the original. So x, when I set that x cubed equal to 0, I can divide both sides by 8 to get x cubed equal to 0. And if I take the cube root of both sides, I get x is equal to 0. So 0 is going to be my only issue here. So I'm going to say everything except 0. And that's what the not equal to means. Let's say we got the next one. We have 6x cubed y squared over 9xy to the 5th. And we want to simplify that. Even though I've got multiple variables, it's going to work the same way. 6 is the same thing as 2 times 3. X cubed is just really 3 x's multiplied together. Y squared is just 2 y's multiplied together. 9xy to the 5th is 3 times 3 times x times y 5 times. And think about what can I reduce. So I see I've got 3's I can reduce. I've got x's that I can reduce. And then I can reduce 2 sets of y's. So what's left over is a 2 times x, which is 2x on the top. And on the bottom, I've got 3 times y times y times y, which is 3y cubed. So simplified form is 2x over 3y cubed. If I'm thinking about what kind of numbers can I plug in for x, that denominator, 9xy to the 5th, is equal to 0. I'm going to have issues anytime I plug in 0 for x or y. So both x and y cannot be equal to 0. So how did I get that? I could think about setting each factor equal to 0. So 9x is equal to 0, and y to the 5th is equal to 0. And you can see where that 0 is coming from. So the next one's going to work the same way. We have 10a to the 4th b over 15ab cubed. So 10 is 2 times 5. A to the 4th is going to be 4 a's, and then we have a b. 15 is 3 times 5 times a times b cubed. So we're going to see some things cancel. The 5's are going to cancel. One of the a's will cancel. One of the b's will cancel. So I'm left with 2 times a times a times a, which is 2a cubed, and 3 times b, which is 3b squared. So there's my final answer. 2a cubed over 3b squared. Domain restrictions always goes back to the original. So a cannot be equal to 0 and b cannot be equal to 0. Okay, so let's make it a little more interesting. Let's say we've got x squared minus 4 all over x squared plus 5x plus 6. So we're going to factor. So the top's going to be a difference of squares. It factors the x plus 2 and x minus 2. Now I'm going to think about that denominator. So I'm going to write it off to the side. X squared plus 5x plus 6. I'm using my AC method. 1 times 6 is 6. 6 is the same thing as 2 times 3, which is my combination to get that 5 in the middle. So I have x squared plus 2x plus 3x plus 6. Factor the first 2 to get an x, leaving me with x plus 2. Factor the second 2, pull out a 3, leaving me with x plus 2. So this factors in the x plus 2 times x plus 3. And the more you factor, the more you're going to see it, and you're going to start being able to do it without writing everything out in that AC method. So we've got x plus 2 times x plus 3. So what cancels? Well, notice we've got an x plus 2 in the top and bottom. So that's going to cancel. So our simplified form is x minus 2 over x plus 3. And if I think about domain, what kind of things can I not plug in? I'm going back to the original. I have x plus 2 in the denominator in the original, and I have x plus 3 in the denominator. So negative 2, these are issues. Negative 2 is a problem, and negative 3 is a problem. So x cannot be equal to negative 2 or negative 3. Let's do one more example. Let's say we have x squared minus 3x minus 10 over x squared minus 25. So we're going to factor. AC method for the top is going to be negative 10. So I can think about 2 and negative 5 or negative 2 and 5. I need 2 and negative 5 to get that negative 3 in the middle. So that's going to be x squared minus 2x plus 5x minus 10. First two terms, we're going to factor an x out, leaving it with x minus 2. Second 2, we can pull a 5 out, leaving us with x minus 2. Now you see those have an x minus 2 in common, leaving us with x plus 5. So if I look at this guy, the top factors into x minus 2 times x plus 5. The bottom is a difference of squares. It's x plus 5 times x minus 5. So we can see that we have this x plus 5 group in common. And that's going to leave us with x minus 2 in the top and x minus 5 in the bottom. So x minus 2 over x minus 5. Restrictions are going to come from setting that denominator equal to 0. We're going to think about the domain in terms of the original. So I need to know where x squared minus 25, which is the same as x plus 5x minus 5, is equal to 0. I'm going to set each factor equal to 0. So negative 5 is a problem and positive 5 is a problem. So x cannot be equal to negative 5 or positive 5. So in this example, they're asking us to evaluate when x is equal to 3. So we've got a couple of options. We can plug it in the beginning, or we could plug it in after we simplify it. I'm going to show you how they're going to both give you the same answer. So let's say we plug it in the beginning. We've got 3 squared minus 1 over 3 plus 1. The original problem was x squared minus 1 over x plus 1, and evaluate when x is 3. Order of operations is I would do exponents first, so 3 squared is 9. And then there's an understood parentheses around the top of a fraction and an understood parentheses around the bottom of a fraction. So I'm going to simplify the top. 9 minus 1 is 8. I'm going to simplify the bottom. 3 plus 1 is 4. And I'm going to end up getting a 2 for this guy. Well, if I want to go the other route, so this is option 1. Option 2 is to reduce it first. X squared minus 1 is a difference of squares, x plus 1, x minus 1, and that's over x plus 1. You can see how these cancel. So I'm going to be left with x minus 1, and now we're going to plug it in. 3 minus 1 is going to give me that 2. So you've got two ways to get to the same answer. In this last one, we have x squared plus x minus 20 over x minus 4. We want to know what happens when x equals negative 2. So we're going to start by factoring. And we factored with the AC method quite a bit. So I'm going to go ahead and factor this guy. Factors a negative 20 are positive 5 and a negative 4. And I always like to FOIL back out to make sure I've got the right answer. So this is x squared minus 4x plus 5x gives me that 1x in the middle, minus 20, all over x minus 4. The x minus 4's cancel, leaving us with x plus 5. And then now they want to know what happens when I plug in a negative 2. Negative 2 plus 5 gives us a 3. So our final answer is going to be 3.